Welcome back, everyone. Today, we will be focusing on a concept that is absolutely central to the study of medicine and the understanding of human physiology: homeostasis. The term homeostasis comes from the Greek words for same and steady, and it refers to the process by which living organisms maintain a stable internal environment despite changes in the external environment. Let's break down why homeostasis is the core concept in physiology and how this understanding is vital in our clinical practice. Homeostasis, definition and importance. At its core, homeostasis is the body's regulatory system to maintain a stable internal environment. This involves keeping temperature, pH, hydration, and electrolyte levels within strict limits. When these are out of balance, the body does not function optimally, and disease may ensue. Mechanisms of homeostasis. The human body maintains homeostasis through several mechanisms. Feedback loops. The most common mechanism is the feedback loop, particularly negative feedback loops. For example, if blood sugar rises, the body releases insulin to lower it. If blood sugar falls, the body reduces insulin secretion. Buffer systems. These are in place to maintain pH. The bicarbonate buffer system in the blood is one such system that neutralizes acids and bases to maintain a pH of around 7.4. Thermoregulation. This is maintained through sweating, shivering, and altering blood flow to the skin. When we are too hot, we sweat, and blood vessels near the skin surface dilate. When cold, shivering generates heat, and blood vessels constrict to conserve heat. Hormonal regulation. Hormones are the body's chemical messengers, and they play a significant role in maintaining homeostasis by affecting the function of organs and tissues. Clinical implications. As physicians, we constantly monitor and manage disruptions in homeostasis. Diabetes, a condition where insulin regulation is impaired and homeostasis of blood glucose is disrupted. Dehydration, loss of water and electrolytes can lead to failure of homeostatic mechanisms. Hypothermia, hyperthermia. Body temperature is a tightly regulated homeostatic parameter, and extremes in temperature can be life-threatening. Acid-base disorders, conditions like metabolic acidosis or alkalosis where the body's pH is disrupted. Homeostasis in health and disease. It's not just about disease. Health is the result of successful homeostatic regulation. Any deviation from this balance can signal that something is amiss, leading us to look deeper into the underlying causes of these changes. Adaptation and homeostasis. It's important to note that homeostasis is dynamic. The body is constantly adapting to changes both internally and externally. These adaptations can be short-term, like the physiological changes that occur during exercise, or long-term, such as those that occur in acclimatization to high altitude. Conclusion. Understanding homeostasis gives you a framework to think about health and disease. It allows you to predict the physiological responses to various situations, from everyday activities to critical illnesses. Our interventions, whether they be pharmacological, nutritional, or surgical, are all aimed at restoring or aiding the body's homeostatic mechanisms. Remember, homeostasis is not just about maintaining the status quo. It's about balance and harmony in a constantly changing environment. As doctors, our role often becomes that of a guardian of this delicate balance, stepping in when the body's systems are overwhelmed. As we continue to explore the different systems of the body, always consider how they contribute to the body's homeostatic balance. It is this balance that keeps our patients alive and well. Thank you for your attention.